So welcome back, and this is our very last maths video for the year. Right, so let's dive in and tackle this last lesson. So we're on page 102. So the first question asks, how many different six-letter word can be arrangements? How many six-letter word arrangements can be made if the letters may be repeated? All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got a choice of 8 letters for the first of our 6 letters. But because they may be repeated, we've got a choice of 8 again, a choice of 8, a choice of 8. 1, 2, 3, 4, 5, 6. So 8 to the power of 6. Okay, so we can write that down. Eight power of 6. And we get 262,144. How many six-letter word arrangements can we make if the letters may not be repeated? Well, now for our first place, we got a choice of 6. For the second letter, choice of 7, then 6, then 5, then 4, 2, 3, 4, 5, and then 3. Okay, so we're just going to have to kind of type all that in, which is a bit painful. 8 times 7 times 6 times 5 times 4 times 3. And we're 20,160. 20,160. Okay. A box contains 3 40-watt bulbs, 5 60-watt bulbs, and 7 100-watt bulbs. 2 bulbs are removed without replacement. All right, so it asks us to draw a tree diagram. So the first bulb that we're going to remove, there are 3 possible outcomes. We either get a 40-watt, we get a 50-watt, not a 50-watt, a 60-watt, or we get a 100-watt. Okay. Now, on the next light bulb drawing out, we again are going to have 3 choices. And here we'll have 3 choices. And here we'll have 3 choices. Right, and I'm going to go in exactly the same order, 40, 60, 100. 40, 60, 100. 40, 60, 100. Okay, so the probability that the first light bulb that we draw out is a 40-watt, well, there are 3 out of the 15 that are 40-watt. The chances of a 60-watt is 5 out of 16. And the chances of a 100-watt is out of 15, sorry, not out of 16, out of 15, is 8 out of 15. Right, now, if we got a 40-watt the first time, the chances of a 40-watt the second time are going to be 2 out of 14. These are still going to be 5 and 7. Right. If we got a 60-watt the first time, then there's still 60 watts. There's still 3 40-watt globes. So this will be 3 15ths. This one will drop to 4 15ths, and this one will still be 8 15ths. This one would be, sorry, not 15ths, these are, sorry, these are all 14ths. All right, so 3 14ths, 4 14ths, and 7 14ths. Notice those add up to 1. Right, if we got a 100-watt globe the first time, then there's still 3 40-watt globes. There are still 5 60-watt globes, so 3 plus 5, that's 8. But there are only 6, and I apologize that I'm kind of running out of space here. There are only 6 there. All right, so there's our tree diagram. I don't believe for part A we need to actually multiply down the branches. Okay, then it says calculate the probability that the two bulbs removed have a total of 160 watts. Now the only way that can add up to 160 watts is to get a 60 watt followed by a 100 watt, or a 100 watt followed by a 60 watt. So the probability of that is going to be 5/15 times 7/14. That's the first branch. And the next branch is actually going to have the same numerators, because notice it's going to be 8. Sorry, this should not be 8. This should be 7/15 and then 5/14. And you'll see that these two fractions are actually the same size, because they, although the numerator and denominator swapped around, they have the same. Right, so in fact our answer is actually going to be twice. 5 times 7 is 35. 35 over 15 times 14. Okay, let's work out what that comes to. So the 2 times 35 I can easily do in my head. That's just 70. And then on the bottom we've got 15. So we actually get a third. Okay, next one. Maria decides to enter 2 different mathematics Olympiads. The probability that she wins the one is that, and the probability that she wins the other is that. Assume that her chances of winning each are independent. Determine the probability that she'll win at least one of them. All right, now, the probability that she'll win at least one of them is going to be 1 minus the probability that she wins neither of them. Okay, so if we think about a kind of a tree diagram, not a tree diagram, a Venn diagram, this is Olympiad number 1, this is Olympiad number 2, all right, and the probability that she wins one of them is 0.02. The probability that she wins the other one is 0.08. Here's where she wins both of them, and we can work that out. That would be, these numbers are not, sorry, got this wrong. I would have to first work out that middle piece, okay? But in fact, what we're interested in is 1 minus this probability over here. Okay, so we're interested in that, or that, or that, okay? So what we're going to do, let's work out this probability that she doesn't win either of them, okay, and then subtract that from 1. So the answer is in fact going to be 1 minus. Now the probability that she doesn't win the first one is 98%, and the probability that she doesn't win the second one is 2%. Is that she doesn't win is 92%. Okay, all right. So let's have a look what that comes to. Minus 0.98 times 0.92, and we get that, which is 9.84%. So there's a 9.84% chance that she wins at least one of them. Okay, penduli ikasi. So we've got these 5 cards. How many different 5-digit codes can be created? Well, the answer to that is just going to be 5 factorial, because we've got a choice of 5 things, then 4, then 3, then 2, then 1, so 120. How many different 5-digit codes can be created if they must start with a number? Well, now we've got a choice of 3 here, all right? And then the other 4 things can just be arranged, so it'll be 3 times 4 factorial. Right, so 3 times 24, it'll actually be 72. What's the probability that the 2 letters are not next to each other? Out of the 120, what's the probability that they're not next to each other? Now, the easiest way to work this out is going to be 1 minus the probability that the letters are together. We're going to count the number of ways with the letters together. What's the trick? That's right, we're going to use a rubber band, all right? So the number of ways that the letters will be together, we're going to put a rubber band around the two letters. And that means we've now got 1, 2, 3, 4 cards. And 4 cards can be arranged in 4 factorial orders, but we've got to multiply by 2 factorial for the letters inside here. So we actually get 48. So this will be 1 minus 48 out of 120. 48 out of 120 is the probability that they are together. So the probability that they're not together is going to be 1 minus 48 out of 120. It's actually going to be 72 out of 120. And 72 out of 120, if we divide this by 12, it's actually, they're both divided by 12, we get 6 out of 10, we get 60%. And guys, that's the end of matric maths. So, hala, well done. But obviously now the hard work starts. Now it's just about practice, practice, practice. Zama, bese, ungobe. Okay, reach out to your teachers for extra help, for questions. Watch the Simi YouTube channel. Watch the Simi Instagram and Facebook for advertisements about revision sessions. Okay, good luck to all of you. God bless you all. Nkulunkulu anibusise nonke.